Welcome to Sigma Solver. Today we are going to discuss how to implement data analytics in a real-life project. For this tutorial, we are going to consider this scenario. Let's say a university in your neighborhood wants to help its students predict their CGPA based on their daily activities. The university has built an app that would track all the student activities and send it to the data warehouse for processing. Moreover, this app has been installed on all the students' mobiles. Now, the problem is how to perform the data analysis and data modeling to predict their CGPA. CGPA stands for Cumulative Grade Point Average. So, being a data analyst, the university has asked you to help them in this. Data analytics is the process of examining large datasets to uncover hidden patterns, correlations, trends, and insights. It involves the use of various techniques and tools to analyze structured and unstructured data, extracting valuable information that can be used for making informed decisions and solving complex problems. Okay, this was a brief introduction to data analytics. Now we'll see what are the different steps involved in it. You'll find that there exists a strong correlation between the working of a human mind and the process followed in data analytics. First, we come to data collection. This involves sourcing data from diverse channels such as databases, spreadsheets, sensors, social media, etc. It's crucial to ensure the data collected is relevant to the analysis goals and of high quality. Techniques like web scraping, API integration, or manual entry may be employed to gather the necessary data. Next up, we have data processing. Once data is collected, it often needs to be cleaned and transformed into a usable format. This includes removing duplicates, handling missing values, standardizing data formats, and converting unstructured data into structured formats. Data processing also involves tasks like data aggregation, normalization, and feature engineering to prepare the data for analysis. Next, we have data analysis. After the data is processed, various statistical and machine learning techniques are applied to extract actionable insights. This involves exploring the data to identify trends, correlations, outliers, and patterns. Depending on the objectives, data analysis methods like regression, classification, clustering, or time series analysis may be used to derive meaningful conclusions from the data. Lastly, we have data visualization. Communicating the findings effectively is essential in data analytics. Data visualization techniques such as charts, graphs, dashboards, and infographics are employed to represent the analyzed data visually. This helps stakeholders to grasp complex information quickly and make informed decisions. Effective data visualization enhances the storytelling aspect of data analysis and enables clearer communication of insights. Coming back to our student CGPA project, we need to perform the first step, which is data collection. Since the app has already gathered information through various sources like screen time, app usage data, and browser history, we will be focusing on only those input features that stand relevant to our project objectives. In our case, it's the relationship between a feature and CGPA. Firstly, we need to ensure that input features are up to date with student activities. By updating input features regularly, such as grades, course enrollments, extracurricular activities, and other relevant data points, the analysis reflects the most current performance of students. With current input features, educators and administrators can identify students who may be struggling academically or are at risk of falling behind. The accuracy of each input feature needs to be considered. If during data collection, a feature is not recorded with precision, it's of no use. The feature that we select needs to hold some value to our goal. In other words, our selected input feature should be a strong contributor in the CGPA estimation. Finally, the most important point, the features should be self-sufficient to identify each student uniquely. Now we'll look into these features one by one. The first one is social interaction. The various social interactions have been taken into account. The students have been asked questions on their well-being. This gave interesting insights to factors affecting CGPA. Next is monitoring sleep. The sleep hours data provided for every student enrolled have been recorded. The student-logged sleep rate denoted the quality of sleep. Even the weekly analysis of sleep duration has been included. Next is sensing data simulation. The app has enabled us to gather all sensing data from the smartphone. We can therefore use various data pre-processing techniques. Finally, you'll see the data model which we will be building helps in predicting GPA using this data. Lastly, we will look into CGPA dependency and its analysis with class attendance hours. The SGPA has also been depicted in our study. While analyzing, we have grouped the students according to their CGPA for better readability. This diagram shows the interconnection between the phone of the student and the student life analysis. In the sensing part, we are using the smartphone. There are two types of sensing data we are gathering. The first among this is automatic continuous sensing. These sensors do not require human intervention to perform its job. They operate themselves and send the data collected to the classifiers above. On top of automatic continuous sensing, we have behavioral classifiers which will classify the data into any of the four types, namely activity, conversation, sleep, or location. Now coming to the other type of sensing data, which is self-reports. These reports are collected based on the answers given by the students who participated in the survey. In a similar manner, these responses can also be classified according stress, mood, etc. Once we collect all these data, we store it in Student Life Cloud and perform the statistical analysis. The various types of analysis are mental health, academic performance, college life cycle, and EMACE. Now we will understand how these dataset features would be helpful towards our data analysis. First up, understanding data quality. Examining features allows you to assess the quality of the data. You can identify missing values, outliers, inconsistencies, or errors, which helps in deciding how to handle them appropriately. Next, we have choosing relevant variables. By studying features, you can determine which variables are relevant to your analysis goals. Not all variables may be useful, and some might even be redundant or highly correlated, which could skew the results if not identified beforehand. Then, pre-processing planning. Understanding features aids in planning pre-processing steps. Depending on the nature of the data, for example, categorical, numerical, you may need to apply different pre-processing techniques such as normalization, encoding categorical variables, or handling missing values. Finally, insight generation. Exploring features often provides valuable insights into the underlying patterns or relationships within the data. This exploration phase can guide the formulation of hypotheses, feature engineering strategies, or the selection of appropriate modeling techniques. Now, we'll look into the specific attributes that how they contribute towards a fairly accurate CGPA estimation. First, we'll talk about Student Life app, which records sleep-related data, including sleep duration and sleep quality. These factors are crucial for assessing students' well-being and academic performance. Then we have stress level. The app assesses stress levels, which is a significant factor in student life, with ordinal responses transformed into numeric values, 1 to 5. This data helps understand stress fluctuations and their impact on students' well-being and performance. Next, class data gauges class enjoyment, ordinal, and study hours, numeric, but doesn't significantly impact CGPA analysis. It measures engagement and study efforts in relation to cumulative grade point average, CGPA. Then we have sensing data that encompasses diverse information sources, including physical activity, audio, conversations, GPS location, Bluetooth, Wi-Fi location, light, phone lock, and phone charge. These data types offer insights into various aspects of individuals' behavior. Lastly, PHQ-9. The PHQ-9, a depression assessment tool, evaluates 9 criteria, such as anhedonia and low mood, using a scale from 0, not at all, to 3, nearly every day. It provides crucial insights into an individual's mental well-being and symptom severity. Now we come to the second step in data analysis, which is data cleaning and preprocessing. The benefits are as follows. Improved accuracy. Ensures data accuracy by removing errors, inconsistencies, and outliers. Enhanced efficiency. Streamlines analysis by organizing and structuring data for easier interpretation. Reduced bias. Minimizes biases in the data, leading to more reliable and unbiased results. Better insights. Enables clearer insights by preparing data for visualization and analysis. Optimized models. Enhances model performance by preparing clean, standardized data for modeling. Let's look into our CGPA project and look what we can do in context of data cleaning and preprocessing. Firstly, we handled missing values in the EMA dataset. We adjusted the values to change to 0 or converted to the most occurring value. Then we removed the inconsistent values from the sensing data dataset. We have replaced the inconsistent and null values with appropriate values. Then we performed data integration over sensing data, where data has been unified that was collected from various sources. Lastly, we performed feature engineering or feature construction over the sensing data. We have used the various statistical methods to aggregate the sensing data into a single score. I will be providing code samples of the entire process in the description below, so be sure to check that out. So, now since we are done with data cleaning and preprocessing, let's dive into the third step and fourth step, which is data analysis and data visualization. The first analysis will be the study that assesses depression using PHQ-9 correlation on their overall well-being and resistance to depressive scenarios. We have used a heat map. The heat map incorporates survey questions assessing aspects of students' mental state, stress levels, coping, and emotional resilience. Darkly colored cells denote strong correlations, such as between stress management and depressive symptoms, while lighter cells suggest weaker or no correlations, enabling tailored support and interventions. Let's take a closer look to understand it better. Next is stress level analysis of students from survey questions. We will be plotting stress level and dispersion using violin plot, which is a modified version of box plot to understand dispersion of data better. The width of the violin at various stress levels represents data point density, with wider sections indicating higher concentration and narrower sections revealing lower concentration. The y-axis represents student IDs, while the x-axis indicates how many times a specific student experienced each stress level, ranging from 0 to 4. Let's take a closer look to understand it better. Next is analysis of CGPA from class attendance hours. We will plot class attendance hours and CGPA on the axis of the heat map. The heat map illustrates the connection between cumulative GPAs and class hours attended, with darker areas showing stronger correlations. A 5-point summary has been applied to remove outliers, and each block's value represents the number of students in that particular section. Let's take a closer look to understand it better. Then we try to find a trend line with the help of the previous analysis, observing CGPA trends with attendance hours. The line chart provides a clear illustration of the overall trend, allowing you to observe whether there's a gradual increase, decrease, or any discernible pattern in GPA as class hours attended vary. The y-axis contains the median of students who attended classes within specific ranges of hours. Try to observe the valleys and hills. Let's take a closer look to understand it better. Next, we are interested in exploring student sleep patterns, a 2-month analysis of sleep levels from survey data. The line in the graph represents the average sleeping rate. In the sleep level analysis of students from survey questions section, a line chart displays the average sleep patterns of all students over 2 months. The y-axis uses a scale from 0 to 4 to represent students' sleep levels, with 0 indicating very low sleep and 4 indicating a high degree of sleep. Let's take a closer look to understand it better. Now, let's try to understand the mathematical correlations between GPA and the features we have studied so far. The study examined academic performance in relation to behavioral and psychological factors using a dataset of sensing and survey data. Key findings highlighted the impact of sociability patterns, study habits, personality traits, and changes in affect and stress levels on student GPAs, paving the way for real-time interventions. This table shows the features and their respective correlation value, denoted by R and p-value that tells about the probability of the distribution to follow the same. As you can see, study duration and indoor mobility at evening have high correlation. Side note, if the value of correlation approaches -1 or 1, it indicates strong correlation. But when the value moves towards 0, it indicates no correlation. As in our case, it's social duration dorm. Let's take a closer look to understand it better. Now we come to data modeling. All this data analysis by itself can only describe the data. But to make predictions, we need a model that can infer the meaning of the analysis and then use the new input to make accurate CGPA estimations. In this study, a predictive model is developed to estimate students' GPA using a dataset comprising sensing data collected from the app. Various regression models, including lasso regression, ridge regression, decision tree regression, random forest regression, and linear regression, are employed to identify the most effective model for predicting GPA. Given the extensive feature set, feature selection is crucial, and the top 30 features are chosen for model evaluation. This process aims to establish a reliable method for assessing academic performance based on behavioral and EMA data, helping to understand the factors influencing GPA. Here is a bar graph that denotes how the various input features contributed to the model building and their impact towards model prediction and accuracy of the algorithm. Let's take a closer look to understand it better. Okay, now this is important. If you're getting to understand data analytics and want to see how the code actually works, I have provided all the links to this project and resources in the description below. Be sure to check it out. Great! So now, let's move to the next part, which is accuracy of the model. Since from the beginning itself we are using the student app tracker, we need to consider the limitations that come with using an app. There can be internet failures, data losses, mobile vendor intervention, and other data collection regulatory policies that might prevent complete data transfer to the cloud. Finally, the aggregation of simulation results from various data modeling techniques, including linear regression, ridge, lasso, decision tree, and random forest, provides a comprehensive evaluation of predictive models' performance. By comparing these diverse approaches, we gain insights into the strengths and weaknesses of each method, enabling informed decision-making for the most effective modeling strategy in a given context. The accuracy values of the model we built is displayed for reference. If you're facing any issues or have any doubts, do write it in the comments section below. If you found this video informative, then be sure to like this video. This help from your side keeps us motivated to keep bringing more educational content for you.
Hey there, before you go, I've got some fantastic content lined up for you. Over here, we've got some videos and playlists you might enjoy. But first, if you haven't already, make sure to hit that subscribe button and ring the notification bell so that you never miss out on any of our future uploads. Thanks for watching, and I'll catch you in the next video.